Let's look at one more example. So this one is a little more complicated. Rectangular poster is to have an area of 100 square inches with a 1-inch margin on the right and left sides, and a 2-inch margin at the top and the bottom. Find the dimensions of the poster with the largest printed area. Okay, so before we try to solve it, let's try to see what this problem is talking about. So you have a rectangular poster. Let's say it's this one. Okay. And so the total area is equal to 100 square inches. And then you have the margin from the on the left, the right, and top and bottom. So for the sides, you know, this margin is a 1 inch. This is a 1 inch, and for the top and the bottom, what you have over here is 2 inches. 2 inches. Okay, so you want to find the dimension of the poster, okay, so that you have the exact area. So now with setting the base and the height being x and y, the area is x times y equal to 100. Okay, so you have this restriction, x times y being 100. That's the size of the paper. And you also want to make sure you leave the margins as instructed. So now the printed area, that's here, that would be what? So the side x minus the margins on the right and left. So for the printed area, the base is equal to x minus 1 minus 1, right? Minus 1 inch for the margin on the left, minus 1 inch for the margin on the right. Okay, now times the height. So height would be the y minus the 2-inch margin at the top minus the 2-inch margin at the bottom. So the printed area has size x minus 2 times y minus 4. Okay, and you want to find the largest printed area. Okay, I mean, if you read the question, you're looking for the dimensions, the x and y, so that you have the largest printing area. Okay, so maybe let me just change this. Find x and the y so that the printed area is the largest. All right, okay, while you have x times y equal to 100. All right, so this is very similar to what we had in in the previous examples. So from here you can say I'm gonna write y being 100 over x. Okay, so now let f of x being x minus 2 times y, but I'm gonna write y in terms of x, so that's this 100 over x, y minus 4. Okay, and we're trying to find the x value, so then y is f is largest. Okay, so let's write this out. So we have 100 minus 4x minus 200 over x plus 8. So that's 108 minus 4x minus 200 over x. So if you want to, you can write the fraction in terms of a power function. So that's this. Alright. So then find critical points. Oops. Critical points. So this is f prime equals 0 minus 4 plus 200x to the minus 2. Okay. So that's minus 4 plus 200 over x squared. Okay. So I'm gonna set this f prime equal to 0 and then solve for x and see what we got. Okay, so what do we have here then is minus 200 over x squared equals 4. So this is x squared equals 200 over 4. So this is a 50. So then x is equal to root 50. Okay. Alright, so now with this x, y being 100 over x. Why 100 over x? Because x times y is the printed, so it's the size of the poster, and it has to be 100. So y is 100 over x, so therefore y equals 100 over root 50. Okay, so this is 2 times root 50. Alright, so therefore dimensions x equal to root 50 and y equals 2 root 50. Oops, I almost want to say will give the largest printed area. Okay, but we have to hold on to this, so this is a common mistake. Alright, so what happens here is I just found, so far at this point I only just found x and y values, but I have not justified they would give the largest printed area. Okay, so in my answers I claimed they will give what we want, but if you look at the solution so far, all I did is to find critical point value x. I did not say, oh, with this x I'm gonna get the largest possible f value, right? So we have to do that. So there we need to do monotonicity, this so-called first derivative test. All right, so let me just copy what we have for f prime. F prime is, where are you? Negative 4 plus 200 over x squared. Okay, and I don't care about negative x because it's the length of the side, so it has to be positive. And we have root 50. All right, so here if I plug 1 into x, then I have minus 4 plus 200. So here f prime is positive. So function's increasing. Now if I plug, let's say 10, no, yeah, 10 is larger than the square root of 50. Okay, so if I plug 10 into f prime, then I have minus 4 plus 200 over 100. So this is a minus 4 plus 2, which is negative. So f prime negative. Function decreases. So it increases before root 50 and decreases afterwards. So this now tells us f of root 50, which is the printed area, is the maximum. All right, so now we are ready to say what we were saying here. So let me move this down. Hold on a second. Move this down. And I can then say what I wanted to say. Okay, so just to make sure that when you do optimization problems like this, you always have to justify why the numbers you have gives you the largest or the smallest, the max or the minimum value. All right, okay, so